G'day, this lesson is going to have 3 videos basically because there are 3 different topics now, but all 3 of them are very closely related. So I'm going to spend the most time on quartiles. And really what it comes down to is that every data set you can break up in chunks, and each chunk can have its own meaningfulness. But the best way for me to describe quartiles is by actually doing it, because as is in the name, quartile basically means dividing any group of data or any data set into 4 groups. But before we can actually do that, we have to put all of these numbers in order, all of these scores in order. And so I'm going to do that now with these numbers. This score is obtained by a golfer for the first 9 holes of a golf course. So I'm going to do that now, and magically it's going to appear in front of you right now. And so what we see is that it's just put every one of these golfers' scores in order, right from 3s to that shocker of an 8. Now, if we're going to divide this into quarters, the best way to divide any data set into quarters is first to divide it in half, and then each half to divide that in half. And so what do we call it when we're dealing with numbers? What do we call the half or the middle number? We call that the median number. And the most classic way for us to actually have worked this out in junior school is to count in from the ends. If we go, that's the last, the next, and where they meet, boom, that's the median number. And so then we see that we've got 2 groups. Okay, there's the bottom half, there's the top half, and there's the middle. Now what we do here, and this is a fairly common, should I say, this is a bit of an agreed thing. We don't include the middle number. What we then do is go from there and count in again, and we have this here, and we go from there and count in, and then we have this here. And so what we've got here is half of the first half, half of the second half. And we call this Q1 or quartile 1. And this we call Q3, which is quartile 3. And really what this actually does is it allows us to break up everything in chunks. And you'll see that a lot of people are going to argue, but what about the middle number? Is that not included? Well, kind of, no, kind of, but not really. So now that we've actually done the quartiles, we can actually figure this thing called the interquartile range. Now the range of scores, traditionally, is from 3 to 8. In other words, it's the highest score minus the lowest score. That's the range. And in this case, it equals 8 minus 3, which equals 5. But if we want to do the interquartile range, what we're actually asking is, what's the range between the quartiles? And we see that the interquartile range, I'll just abbreviate it like here, is Q3 minus Q1, which in this case, what number lies in between 6 and 6? Well, it has to be 6. And what number lies in between 3 and 4? Well, it has to be 3.5. So 6 minus 3.5 is 2.5. So the interquartile range is 2.5. Now, why does this actually matter, or why is this meaningful? This is meaningful because we see that half of all the scores lie in between Q1 and Q3. In other words, the middle chunk of the scores, we see are really quite close together. There's only a range of 2.5. Whereas when we see the range right from the beginning to the end, we see it's got a larger range of 5. Now, in this case, it doesn't jump out at you. But sometimes you get data sets where the interquartile range is really quite conservative, and then you see that the range is really, really drastic. It's just another way of actually analysing the data and saying, well, the middle group are actually a little bit more closely related than the whole group themselves.